Hi and welcome to another Coiro video, and this time it's the 5th installment in my Commodore Resurrection series that is a celebration of the 40-year anniversary of the Commodore 64. And this machine, as you can see, it actually works. But we do have an issue with this machine, and that is a broken keyboard switch for the F7 key. So we are going to take it apart and take a look inside. And as you can see, this machine is made in England. And as you might know, they laid down the production in England and moved everything to Germany of the European produced Commodore 64s. This machine actually has the writing above the ports, and I do have 2 or 3 more Commodores with this writing, but it's not very common. And as you see, this machine lacks a screw. That's not very uncommon either, and it means that someone has been inside. And there are almost no C64 at this point that no one has been inside ever. And there are no warranty stickers on these old breadbin computers, only on the newer C64Cs as far as I know. This C64 looks rather good, but there are some damage in the plastic here above the sign. Otherwise it looks quite nice. And the case is not broken in any way, all the plastic pieces are here, and the IO shield looks to be in really good condition. And let's see what version of the motherboard this is. Oh, this is one of the newest versions. This is actually the last version until they made the ones with just 2 memory chips. And this also has the cost-reduced tin can over the VIC-2 chip that actually is soldered in place. And on this board it's only the SID chip and the VIC-2 chip that is socketed. Everything else is soldered to the board. And the date codes on these chips are all 1985, and that's except the SID chip that is 1984. So this is a very late production C64, at least from the English factory, as this was closed down in early 1986. And then all the rest of the C64s that was produced in Europe was produced in Commodore Germany's Brunswick factory, as far as I know. Yeah, but now let's take a look at the keyboard, because as you can see, this is a very special keyboard. It does actually contain a round hole for the caps lock key, and I have seen this before, but I really paid no attention, and this is not similar to any of the other keyboards that's used on the Commodore 64. It's not the same as the newer cost-reduced C64Cs. It's not the same as the C64Cs with the signs printed just on top. And it's not the same as the keyboard that's on the C64C with the signs in front. So this is a really special beast. So the question is, will we be able to pick some replacement keys from another C64 keyboard? So let's look into that. Here I have a spare key from another old C64 board. I will pick out another key just to make sure that everyone is the same. And as you can see, the main difference is that the stems are black and they seems to be placed off-center. Yeah, on the top they seems to be made of the same mold and they look exactly the same. But on the bottom you can see that they have one insert in the middle on this keyboard, and the old one has 2 inserts instead of the one. And that of course means that we can't replace this key with one from another standard or common C64 keyboard. So this I have to search a bit more for to find more information about. So for now we just put the lid back on and put everything back together, as this machine is working and you can actually use the key anyway because you can just push on the plunger. I was thinking that we need a short walkthrough of the different keycaps and the different keyboards for the Commodore 64 and this family of computers. So I stitched together this photo montage of the different aspects of this. And here to the left you have the original C64 keyboard. And this is the same keyboard that was on the later VIC-20s. The earlier VIC-20s had a bit different keyboard with a bit different font and print on top, and there also was some slight differences in the molds that were used. And we jump over the special mysterious keycap that we have here, and we have the mostly used keycap on the original C64 breadbin. They are mostly the same. There are some variations where you do have some difference in the thickness of the walls and so on the plastic mold that was put inside the key. And you can clearly see here that this is a different plastic from the top case, that is the brownish color, brownish gray. This variant is the most common one. And then you have this variant over here that almost looks the same. And this is the variant used on the earliest C64Cs and also some other variants. But this is the keyboard that's on the C64C where you have the printing of the special PETSCI characters on front of the key. And this uses a molding that's similar, but it's slightly different. You can see you have no corner posts as you have in this one, and also this one is slightly different here in the center. But these keycaps actually, you can place these keycaps on this one and vice versa without any problem. And the same with this original one. And then you have the keycaps for the newer Commodore C64Cs and also the other variants where you don't have print on the front of the keys for the PETSCI characters. And this again uses a slightly different mold. And here you can see that this is molded in one piece. There is just one layer of plastic. So this is simplified and cost reduced in two ways. Just one simple molding of plastic and just printing on the top of the keys. But these keys to some fashion also works on these older key mounts. There are some differences in this I've seen with how long the stems on the keys are. And I also taken a picture of a key from a C16 keyboard. The C16 was made about the same time as the breadbin over here, and you can see that this molding looks very much the same as this one when you look inside here. And this is also a two-piece plastic with this black material on the bottom and a slightly other gray color on top. You can also see there are some variations on the top of the keys. They do have a slightly different form, and this should be the same key all over. It's the function key that is second to the bottom. It's a slightly different numbering on this on the C16, but it's the same key. And you can see that this has a slightly larger surface on top, and these are slightly smaller. Otherwise, the keys looks, they look from the top of the keyboard, it's very difficult to see what's beneath. And that brings us to our special key. And the keyboards for the C64 was mainly made by the same manufacturer, and it was Mitsumi, as far as I know, that manufactured most of these, and that's also true with the Amiga and C128, as far as I know. They have made this rather strange keyboard here where they actually moved this placement of the stem, and it's only one of these stems that are used on these C64s, even though you have two of them. But here they have moved it in the middle, and that's actually not a bad decision. I would think from a mechanical construction and stability view, this is a better solution than this one. But it means that you can't use these keycaps on these kind of stems, and of course not the opposite way either. And I do know that there are some campaigns for making new keycaps to the C64, and obviously this is not something that has been in those making, because it's very few C64 that actually has this keyboard. And I will take a careful look through all the rest of my C64s, and I will take and lift one of the keys to see if I have more of these keyboard, to see how widespread this is. But as far as I know, And as far as I've been able to check out for now, this is the only keyboard I have with this kind of stem. So until now I can't repair this keyboard if I can't find the original key and glue the stem on top of this key, because there really are no options. I can of course doctor one of the other keys and make a new fittings inside here, and that's actually possible to do with some Lego stuff and others to make this fit, but until then I will just wait and see. And the key is actually working. The plastic stem, I can push on that instead of the key and it actually works. So that is as far as we go on this computer this time. We will lay it just back on the shelf until we find some more information about this kind of keyboard. Yes, but stop, don't turn off yet. As far as I'm concerned, we have not done any repair yet in this video, and if we don't do any repairs, then it's no C64 Resurrection. So we are actually going to tackle another board in this this series, and this is 2504-25 board that we are going to look into. And this board also has some rather simple faults, but at least it will be a repair, and we fix 2 faults on this board, and I think both of them has interesting faults that it will be a valuable introduction into repairs. This is faults that's not uncommon to the C64. One of them is very common, and the other one is more common due to other people has been handling this board before we got it here. So now on to this repair. That will be the rest of the video, and hopefully you will enjoy the content. Yeah, and this board is a 2504-25 board and looks rather nice. It's actually no visible damage to the board, and this is a PAL board, as you can see. And the board are lacking some chips. The kernel is gone, so is the CPU. And you can see the 2 CIA, there actually has been some change, at least on one of them, because they're not the same. And SID and the PLA is also missing, together with the VIC-2 chip. Yeah, we will just mark this board as number 5 in our Resurrection series. Yes, and as long as we have out the VIC-2 chip and the SID chip, we are going to take the opportunity to measure some voltages to see that we don't have some fault in the power supply to the expensive chips. Yeah, I will just put the meter into DC voltage measurement mode. Yeah, and I forgot to put in my power LED. I mount this so that you can see if there are power to the board. And that you cannot. It's not lighting up, so I do think there is something wrong with the power supply into the board. But let's measure that. Yeah, first we measure on the internal 12 volt regulator, and it's only 0.5 volt something. And 5 volt regulator is 0.26, so they're clearly not functional. And then we measure on the capacitors just to confirm that we don't have, they're far too low, the voltages inside here. And this is the 5 volt out of the switch, and as you can see it's 0, but I can find the 5 volt on the input to the switch. Yeah, and also on the output of the 9 volt AC it's about 0, so it's clearly something wrong with the switch. So we have to address that first. And yes, the scope meter is able to measure AC voltage on the DC settings. It will just overlay it on any DC voltage, same as an oscilloscope would do. Yeah, so we just plug in and heat up our desoldering gun and desolder the power switch so that we can take a closer look at that one. Desoldering of the normal 6 legs goes very fast and okay with this desoldering gun, but the ground plane where this has fastened in the end needs some additional work, as it's not possible to heat up all this ground plane good enough to suck out all the solder. And I just used the continuity tester on my Fluke to measure out this switch. And as suspected, we see no continuity at all in either of the switch positions, and this is an on-on switch. This is the same switch that was used in my last video. Not the same switch, of course, but the same type of switch that was on the other board. And there was some information that I skipped in that last part, but here is to give you some pointers of what to expect when you measure power into a C64. First, this is really a on-on switch, but it's used as an on-off switch. And these switches are delivered also with a center position, but in our case, this switch is just a switch with two positions, it's up or down. And what's really happening, if you see on the schematic here, is that you only have one position mentioned in the schematics, and that's on-off. So the resting position of the switch does not connect to anything. And if you see here on the switch itself, it's the back legs that is not connected to anything. And if you see the switch from the top, it's the leftmost pins, that the 5-volt input, and the rightmost pin are the AC input. And as you can see here, it's just one of the lines for each power supply that is switched. So the ground level is not broken, and neither is one of the AC lines. It goes straight into the fuse. So that's what we have to deal with. So when I measured into the circuit, I measured from ground and to one of the AC lines, and I got some voltage. And when I measured out of the switch, I got nothing. But I did measure the 5-volt input to be present on this pin here, but not on this one. And the same with the AC input. It was present on this one, but not on this one. And if you want to measure this yourself on your C64, you can actually measure this with ohm or continuity tester from the pins here on the side of the C64 and to the pins on the switch. And then you have to use these holes over here, and this is how this looks when you look into a C64. And the same if you are going to measure that this switch actually works. You do have some schematics here where there are some numbering of the pins, but that does actually vary from one manufacturer to others. You have the schematics down here regarding to what is connected when, but it's not very helpful if you just want to do a quick test. So the quick way to measure this is just to measure between these pins with a continuity tester and rock the switch. And if this doesn't change, then you know the switch is faulty. And in one position you should have continuity from here to here, and in the other position you should have continuity from here to here. If you have continuity from this pin to this pin, you know something is broken. And the same if you have continuity from this pin to this pin, then you know something is broken, and then the input is short-circuited. And the same with the other pins. And one common fault back in the day was actually faulty switches where the 9-volt AC could be connected to the 5-volt output. And in those cases, you changed the switch, and you also had a lot of faulty RAM chips and maybe some of the other logic as well on the board. So this basically is what happens inside your C64 when it's connected to power. You first have your power connector. You have the drossels that's meant to suppress noise. Both the lines on the 9-volt AC goes into this inductor, and the plus 5 volt also goes into an inductor. This goes straight to the fuse, and this goes to the switch, and then it goes to the rectifier and the other circuits that's behind the 9-volt AC. And this 5-volt here, it goes straight into the electronics and all the supplies of the TTL chips and the other chips that's not inside the metal tin can for the VIC-2 chip. Yeah, the switch measures bad, but I do think that there is a possibility that we will get this to work. So I will try to pry this open and see if we can clean it to make it work again. Sometimes it's just corrosion, and sometimes people has been spraying this with spray that leaves some residue that's not good for making contact over time. And I have found this metal in these switches to be rather soft, so it's possible to pry this open with relative, if you have the right, or in this case the wrong tools, it's possible to do this. And I don't think I ever have broken off the metal pieces that was bent to keep this in place. In some switches there's a lot of springs and other things that come flying at you when you take them apart, but these switches are rather boring in that regard. And I will show you here a close-up of what's inside this switch together with the picture when we are dismantling it and cleaning up the parts. And it consists mainly of the rocker part, and it's 2 leaf switch blades that does have a slight arc and do the actually pivoting of the switch. And you have the contact point in the bottom of the plastic house. And that's really all there is to it. And in my opinion, the switch will corrode, and it will have some corrosion on the contacts, both on the side of the levers and on the bottom contact point. So that's what we are going to clean on the switch here and see if we can get this to make contact. I will clean this first with isopropanol, as there is some goo on this, and this is either lubricant that was put in the switch when the switch was made, or some residue from some spray cleaning attempt from years past. The surfaces themselves appears to be silver coated, so I will just do a quick scraping and do some manual removal of residue with this pointy object. The surfaces actually looks quite clean, so I suspect that the goo that was put into here was forming some kind of layer that's not entirely visible to the eye. So I think the isopropanol together with this scraping will make this switch in perfect operating condition again. Putting it all together again is really quite simple, because you don't have any springs and other things that could go wrong and run away from you. So it's just putting in the levers and putting the bottom back together with the top. To make the assembly easier, I'm using these pliers to straighten out these metal pieces that should keep this together. And then I just use the pliers again to fix the bent metal pieces so the switch won't open again. Then it's just straighten out the legs, and we can do a quick measurement with a continuity tester to see if it's okay before we put it back in place. Yes, this now measures good on every account, so I think we can call this a success, and we will just solder this in again. As the card was dead, we're just doing a quick power test, and you can see the LED comes on at once, and then you can turn it off and on again with the switch. So the switch is working totally fine. But now we are back to actually measuring the voltages again and see what we have as input to our chips on this board. And of course I forgot to move the multimeter, but I can assure you all the voltages now measured just fine. Also on the 5-volt rail from the power supply brick. And we also measure in the user port, and it's also about 5 volt. So far this seems like a success. And then we start by pulling out the chips we need from the last board we fixed, board number 3. And we are going to borrow the missing ships, the PLA, the SID ship, the Vic-2 ship, and the missing room ship. And I'm using my semi-automatic ship puller that I got from my brother. If the ship is not too stuck in the socket, it's actually quite a nice tool. But if the ship is stuck in the sockets, I don't like to use it because I don't feel I have the necessary control to as not break the ships. And also we have some limitations here on the Vic-2 ship where I put on this cooling fin. And as the CPU is soldered in on this board, I have to find a new on-shelf part in my parts bin. I actually have quite a few of these now. And now we are ready for some testing. I just plug in the video grabber and try to turn this on. And we get the picture, but it's garbled in some way. There actually seems like there is a fault, maybe in the character ROM or something. I have to analyze this a bit further, I think. I will just try with an ordinary monitor to see if the picture is about the same. Yeah, and it is. So we don't need to test this further, we need to do some fault finding. Yeah, and straight away when I inspect the board, I see something that does not look quite right. And you can actually see the pins here on the character rooms, they're standing outside the socket. As we did or did not see from the overview of the computer, this should be a fault that was easy to spot. Because these pins here was clearly not, they was somewhat in contact with the sockets, but they clearly was bent and not fully in contact with the socket. And that's something that happens a lot with old sockets and people that's not experienced to put this right. And also people who does this every day make this kind of mistake. But what really is happening here, and what was that triggered me to look into the character ROM when we got this picture on our C64? And each character on a C64 is made of a binary mask, that is 1 byte for each line of the characters. One row down here is represented by 1 bit. And this is counted from for the most significant to the least significant bit. So what you can see here is that you have this A is really not affected at all, and you can see where this line passes through the A. And that would be to this pattern here and to this pattern over here. And that is the data bit 2. We start on 0, 1 and 2. And if we see here on the 2332A, that's the character ROM, you see that D2 is pin 11. And the pins you have on the side here is from 1 to 12. And you can see pin 11 is D2 and that's this one. And D1 is this one here, that's pin 10. And you can see some noise here on some of the characters on that pin, but not everything. So this clearly is a fault with the output of the data from the character ROM, but this could also be stuck bits everywhere. But the 64 is running as it should, and it reports the right amount of memory. So we do have to look other places than RAM and the data bus to explain what's wrong with this. And then the character ROM is our first place to go. And you can, of course, get a picture that looks totally different from this if there are other bits that are stuck, if there's more than 1 bit that is stuck. And you also have another fault that's happening with these 2332 ships as they're getting old. These are masked programmable ROMs, and a masked programmable ROM can lose its connection over time because of corrosion. And then you can miss data inside a character, which means that your character set can be okay, but maybe you're missing the 4 character or the B character, or there is just one extra dot inside an R or something else. Then it's obviously the ship itself. But if you get this kind of fault, it's more likely that this is an external fault. Bad contacts in the sockets, bad solder joints, bad connection on the main board, or something like that. Because you can see this fault is not completely stable, if you can say that about a fault. It actually varies a bit. And this is consistent with a bad contact. And as you can see, these bent pins that was over here was making contact most of the time, but it was a bad contact. That meant that sometimes it actually had contact. And this is completely different from finding faults on the other ROM chips, because the other ROM chips contains program code. It just does not just affect your display, it actually affects something working or not on the computer. In this computer you probably can use it to run most of the programs, but there are some programs that depends on the bits and bytes in the character rooms, and these of course would have had problems with this. And also because this is an intermittent fault that is not stable over the entire cycles of the bus, you of course could have issues where this was making noise on data bit 2 and also was affecting other parts of the system. Yeah, we will just try to bend these legs back with these pliers and try to fit it back in the socket and see if the picture got rid of this strange artifact. Yeah, so that's it for another video in my Commodore Resurrection series, and this time it was part 5. And this time we also looked into 2 Commodore 64s, and the only thing we did repair was this board. And it actually had 2 faults. One of them was the faulty power switch that we fixed by dismantling the switch and cleaning it and putting it back together. And then it was the character room chip, which had the legs sticking out on the side. And that's clearly not a common fault. That is because these loose boards that I have got them from other people that has given up on them or taking parts from them or whatever. And this is clearly a fault that's... Maybe it was when they removed the chip, maybe it's been there since they tried to repair it. I don't know, but it was quite an easy task. And I did manage to get in a bit of explaining how the character room normally fails and what you should do to fix those kinds of errors. My next video in this series will again be in a complete system. I am not decided on which. But I do know that I have 2 non-working Commodore 64 with the small board. And I might be looking into them. I don't know if I have the parts. but I do have some working systems that we can play around with to see if we get them to work. So, hope you enjoyed the contents. Please hit like and subscribe if you want to be notified when we post new videos. And hope to see you in the next one. Thanks for watching.